So, welcome tonight for another edition of our talk series on distributed knowledge graphs. Tonight we have Terry Payne, and he will talk about autonomy, the web, and semantic web services. In case you've just changed channels and you don't know what this is the talk series on knowledge graph research, where we've had a few talks already, and there will be more to come. We started out with a panel in 2021, and now we are in 2023, in October, where we have Terry Payne. In December, we will have the next talk, and there will be more to come in the year 2024. This thing is organized by the Cost Action on Distributed Knowledge Graphs, which is a European research network where a lot of countries are represented. We organize workshops, hackathon, short-term scientific missions, and this talk series here. Especially, I want to highlight the short-term scientific missions, where from the end of the year or early next year, we will open calls again, where you can go on a research visit to another country to work on the topic of the action. The action will only run until September next year. So get your applications ready in time. The whole thing is run by myself, Tobias Käfer, Axel Polleres, Michel Dumontier, Ramses Chelebi, Andreas Hart, Antoine Zimmermann, Olaf Hartig, John McCrae, Anastasia Dimou, and Stefan Gostric. For tonight, we have Terry Payne. He's a senior lecturer in the Department of Computer Science at the University of Liverpool. He's done his bachelor's in the University of Kent, and he has his master's and PhD from the University of Aberdeen. He's been to many places, including the US, the Netherlands, and then also back to Britain, where he is still located today. He's working in the area of agent-based computing and knowledge-based systems since quite some time, the mid-90s, and he has a specific interest in the use of ontological knowledge for the support of autonomous service discovery and provision. And I guess this is also the starting point for his talk today. And with that, I want you to get ready. One remark, afterwards we will have a Q&A after the talk that will be hosted by Antoine Zimmermann. Until that, I want to say thanks, Terry, for accepting our invitations to speak here, and looking forward to your talk. I will now stop my sharing and hand over the sharing rights.
Okay.
To you.
So let me just get desktop shared and start the talk. So just to check with you, you can see the slides, is that correct?
I can see the slides.
Brilliant. So Tobias, I want to thank you and the whole of the Cost Action for inviting me here to have the opportunity of talking about, well, autonomy, the web, and semantic web services. I've used that title partially because of some of the work I've been doing, over the last 25 years, but specifically how it got me into looking at the notion of semantic web services, and specifically DAML-S. Because of course, with DAML-S, we were actually really fortunate to win the Distinguished 10-Year Prize from Swizzer on our paper that was actually presented at the very first ISWIC back in 2002 over in Sardinia. I always stumble there because I remember actually the very first time we published this work was in the Semantic Web Working Symposium that was held in Stanford, which arguably was the precursor to the to ISWIC itself. Now, part of the reason why I got into the notion of services and semantic web services is because my background is actually in multi-agent systems. And I wanted to start by talking about agents because having been between that situation of the semantic web and multi-agent systems, I've often seen both communities not fully appreciate the advantages and the synergies that you can get from both. Some colleagues can, but often the communities never quite see this. So I want to remind everybody what autonomy is, why knowledge has always been central to the notion of agents and their collaboration, how that fed into actually the establishment of the DAML program and DAML-S, and then what's happened since, and a bit of a reflection on, did we get it right? How did the semantic web wars turn out with, OWL-S versus Wismo? I mean, it was good-natured. There was really great ideas from both camps, but what was the emergence of that? So let me remind you of, from a perspective, multi-agent systems really came from the good old days of AI, where we realized that we couldn't solve AI problems in a centralized way. So we needed to distribute them. Machines simply weren't capable of actually solving a lot of problems on their own, because maybe a machine or a system didn't necessarily have the capability. So by distributing and having decentralized systems, you'd potentially be able to ask, is there another entity out there who can help me and solve the problem that I'm trying to solve? So do you have the capability? And you've got to think about, how do you describe that capability? How do you communicate with respect to requesting that capability in some way to achieve a task or to return knowledge? Of course, then there is the problem of knowledge. I want to do something, but I don't know that information that I can exploit and use. Can I get it from a third party? Now, if you go back to the late 90s, one of the things that we were doing was often screen scraping. The web was a fantastic resource of information. This is before the semantic web, but what we had to do was often screen scrape it, which, when you've got a proposal or a demonstration to give to your funder the following day, only to realize the website has changed, would be an absolute nightmare. So you want a more formal and more structured way to not only obtain that knowledge, but reason over it. And of course, there's the other issue of computational capability. You may run your system on some machine, but is it a large-scale server? Is it a small handheld? Perhaps you need to handle that capacity to somewhere else. Or perhaps, back to that original idea, there's too much processing that a single individual can do, or a single entity, and it needs to distribute it. So much of what emerged from the research on multi-agent systems actually was to say, how can we do task solving in a distributed way? So it wasn't necessarily saying how you solve the task, but if there's going to be, in a decentralized way, more than one entity that's actually solving that task, then how do those entities coordinate with each other? How do they even find each other if you're considering an open, scalable system? So there are the issues to do with a society. Agents need to be social. They need to be able to identify each other, be aware of each other, or aware of agents that could provide the capability that they want. If you're doing distributed problem solving, be aware of what knowledge the other agents have in trying to establish their goals. Now, you may wonder, why is this relevant from a software agent perspective? Some may argue it's not. But if you then think about, for example, robotics, where a robot is a physical manifestation of an agent that's trying to achieve something, the collaboration between these things and the sharing of knowledge is absolutely crucial, especially if you consider that a robot only has partial observability of its environment, partial awareness of the other robots that it's collaborating with. And this might be, for example, in a disaster scenario environment where the knowledge is rapidly evolving and emergent. So you need a system that can support the actual doing of stuff. Whatever that stuff is, you still need the support to allow it to actually manifest in some way. And there are a number of examples that were emerging back at the turn of the century. Certainly, a global phenomenon was the rise of e-science. And there was a large-scale program in the UK for the e-science grid, where we were thinking about the fact that we often had to analyze large amounts of data that came from different workflows, scientific workflows. This could be from the wet sciences, such as chemistry, biology. A lot of bioinformatics was being done this way. And so they were coming up with machinery to consider, how do you actually migrate pieces of code, we call them viruses, but to other systems, be able to analyze the data, to build up some form of data analysis. There may be learning that's going on that would be shared. And this is a quote from Foster from his original book with, I think it's Foster and Kesselman, if I remember correctly, on the grid, saying that much of what's happening with the grid community and the systems we're developing, that was the brawn, this was the processing. But the brains was actually agents. So agents have focused on brains, the development of concepts, methodologies, and algorithms for autonomous problem solvers. So this was the glue that would allow these services to somehow work together in an autonomous way without having, a scientist having to sit there 24/7 clicking at the right time. But of course, the problem with all of these agent-based systems, as much as they were making use of knowledge and trying to share this knowledge, there was a number of different systems with often different interoperability issues. For example, there were systems such as the Retsina system that came from Katya Sakara over at CMU, which had a peer-to-peer based system. They discover each other through a centralized repository. Whereas the OAA that came from David Martin, Adam Chaya, etc., assumed there'd be a centralized point of coordination for these different agents. How do you bring these together? Because they have fundamentally different architectures. Likewise, if you consider other teams, you had Team Core that was thinking about how can you coordinate a number of different agents in solving a task, as opposed to the work that would come from Carlos Sierra in Spain, thinking about electronic institutions where different agents have a very different purpose or a different role in the way they work. So there were these different scenarios. And I remember even working with one system whereby even you had problem with a system running on a PC versus Unix, because at the time messages were sent with or without a carriage return line feed. So we had these these interoperability problems, whether they were down to how you end a string, what the format of that string is in syntax, and specifically semantics. What's that knowledge you're sharing? Now, in a way, that was odd because much of the work that evolved in multi-agent systems built on the early knowledge efforts, and specifically the DARPA-funded knowledge sharing effort that had brought to the fore languages such as KIF, so the knowledge interchange format, which is effectively a first-order fragment that was used to describe ontologies and present knowledge. So very much a forerunner of what we think of nowadays with the semantic web and knowledge graphs. But it was first order, so it had all those inherent problems. And then there was KQML, the knowledge query markup language, which was designed following on from Searle's work on speech acts to be able to present fragments, but then ask specific questions and follow that means of communication between agents. We've seen something similar in the web service community with SOAP, but it was looking at how you facilitate communication between different peers. But of course, even then, we hadn't resolved the issue of two agents that may assume a different ontology, and therefore, how do you align them? What about reasoning? How do you break away from the notion that you still encode everything with the same semantic assumptions, which had been holding up agent-based systems? And around that time, Jim Hendler, who I'm sure most of you already know, actually was working at DARPA, and he came up with this idea of the control of agent-based systems with a vision to bring these different autonomous systems together and overcome the issue of heterogeneity in their architecture. And in a way, this was really successful. One of the things that it produced was middleware to support different architecture interoperability, security support, logging support, the discovery of services. Although there were two fundamental problems that we actually found with this. I'm going to put this slide up. And that was either debugging, and that actually caused the development of the task program that was looking at how you can actually develop and test out multi-agent systems, but also in the way we could actually put together and define knowledge, i.e. semantics. And interestingly, I've just put this slide up here because we would often argue that within our technology integration experiments, we could put these different systems together. This is a video that was created at CMU, looking at multiple different agents in different architectures, being able to actually coordinate them and cooperate in a dynamic and evolving scenario. And we claimed at the time that we could do it in 2 weeks. It really came together really quickly. What was not said is those 2 weeks ignored the 6 months that was spent agreeing on the knowledge models, the ontologies, the meaning of each of those terms. So for all that we could claim about the coordination of agent-based systems, the semantic interoperability was still a major issue that we needed to resolve. And as the other subsequent program was the DARPA Agent Markup Language, or DAML, which in a way has kickstarted the semantic web. A number of projects. It was very much an American-focused thing, but with some international collaboration at its inception. But one of those collaborators was Tim from MIT, who proposed his part of the project, the semantic web. Very quickly, what DAML focused on was the issue of trying to encode knowledge in some way and make it distributed, building on top of the web infrastructure. So, I'm having watched one of the talks you gave you had from a couple of years ago from Ian Horrocks talking about the evolution of OWL. I thought I'd put up this slide, taking you back to that notion of the brilliant work that was coming out of Europe with the Autonomy project bringing through OIL, whereas in the States, we had teams looking at how to build on top of RDF, RDFS. Again, you had Aura talking a wee while ago, and he fundamentally was with Ralph Swick in developing the initial specification of RDF. So we come up with the notion of DAML-ONT to describe that knowledge that could be distributed, making use of and exploiting the ubiquity of the web and all of its standards. But very quickly, we realized there was great work coming out of Europe and the ontology projects as well. And the joint EU-US committee ended up publishing DAML plus OIL in 2001. And that became our initial framework for doing any work on the use of knowledge. And of course, we know the story from there, from a semantic web perspective, with OWL and its flavors, moving on through to OWL2. But again, whilst we're now thinking about knowledge, we're thinking about encoded knowledge, semantic knowledge, RDF fragments, and all of the tools that have emerged ever since. There was still that argument about agents being within the semantic web. In a way, we didn't necessarily talk about what we got from the autonomy, but this is a picture I took from when Tim Berners-Lee was actually at the Olympics in London in 2012. But he had this argument back in that original semantic web paper, saying that I have a dream for the web. I won't read it, but it's thinking about the semantic web where you'd be able to not only share knowledge but make use of knowledge to support transactions. I remember talking to him about how by having ontologies out there, you'd be able to see any transaction, bank transactions, and be able to reason about the correctness of those transactions because of that distributed knowledge. And that happening irrespective of however many ontologies out there, because the knowledge would be there within the domain. But it still was seen almost as if this could be the time where intelligent agents could finally have their day. Of course, this didn't take into account that the agent community at the time were discovering game theory and an alternate way of actually coordinating. And they almost started to diverge from the notion of knowledge. But we were tasked as part of the DAML program to actually look at how we can make use of these emerging ontological frameworks for services. So one of the challenges was the fact that we were seeing web services emerge on the web, actually for the last 3 or 4 years at that point, which admittedly were human focused, but they could be used to elicit knowledge or to affect the world. So in a way, they were that capability part of an agent, but without any of the agency that sits around them that makes them autonomous or could make them autonomous within an agent systems. And of course, web services were incredibly captivating because there was ubiquitous syntactic support provided for them. They were found in a URL, they were accessible through firewalls, through port 8080. You had the XML infrastructure there. There was nothing really to dislike about them at the time. Communication wasn't as we would have liked it from a KQML and KIF perspective, but we had RESTful services or WSDL descriptions. So as long as you knew how to invoke a service or interpret the results of the service, you could still make use of it in some respects. And typically you would find that services fell into, broadly speaking, two camps. I'm sure there'll be people out there who would argue with me, but you'd have these functional type services. You send a request and you get a response. We used at the time the example of requesting the price of a stock, for example. But then if you think of how you would book a flight, for example, you might have a dialogical encounter where you're trying to make use of a service, but you go through a series of steps in order to achieve your goal. You don't simply send all the information at once, but rather you send a fragment, you get some results back, you'd have to interpret those results and follow up with another knowledge fragment. Think of what happens when you book a flight and you're checking flight availability. So interestingly, and I just wanted to throw this slide in, there were a number of elements that had an overlap between these three areas: the semantic web and web services. There were good descriptions, XML-based descriptions. Standards were incredibly important, and there was a huge amount of effort going in, from around the very late 90s through to the I would say even nowadays, but certainly there was a huge amount of activity in the service field around that early part of the millennium itself. But multi-agent systems were still there. They could still exploit and make use of this data. So I wanted to just throw that as showing how these things could come together. So of course, in the DAML program, we formed the DAML-S coalition, and you can see many of the members across there. So there's Anupri Ankaleka, Mark Bernstein, Jeremy Hobbs, Bora, you've got Dave Martin, Drew McDermott, Sheila McCorath, Sri, Massimo, myself, and Katya. And we were looking, and this, we worked on the original work. Many others have joined us since, so have made great contributions to OWL-S and the later versions of OWL-S. But the idea was this odd mix of trying to think, how can we build services that had an ontological foundation that you could reason over, that would then allow them to be used in a greater context. So, interestingly enough, there was work that was somewhat similar to that going on in Europe, which I will be honest, wasn't necessarily having a bearing on the view that we were taking. And that was the work for problem-solving methods and the notion of projects such as Eyebrow that were looking at how you could actually use services to generate more information that you could make inferences over. We were looking at this from the perspective of how do you describe services in a similar way that you would describe agents, or rather the capabilities that agents would offer, how you could actually then take these and compose them. Because of course, again, if you're thinking about taking an AI perspective in achieving some goal, you might make use of a planner. And planners go back easily to the 70s and 80s, the classic one being strips from Stanford. But we were using hierarchical task networks and other methods to try to compose these different atomic elements to put them together to achieve a stronger goal, which has had real value from that knowledge path that we're considering. We also wanted to understand and examine the execution and ground that execution in these new standards that were emerging from the semantic web, or rather the web. And many of our aims were, how do we solve the issue of locating services? How would you have knowledge of those services that were out there, especially in a dynamic environment? So you'd need infrastructure to allow their discovery. And I suppose I should also give a nod to Massimo's paper, because he actually won the 2011 dissertation award, if I recall, on looking at how we could actually embed part of OWL-S with UDDI, because UDDI was otherwise a way of finding services at the time. Thinking about how you could get potentially this form of dialogical communication or transaction, how we would think about invoking those services that were distant and grounded on the web, such that you could then exploit the data they were providing. And of course, using the machinery that was emerging from the rest of the DAML program and the wider semantic web effort in interpreting the results that you would get from the services. But most importantly, how would you be able to put those services together? Now, I must confess, over the next few slides, and I'm going to skim through these really quickly. I'm sure you don't want a full tutorial on OWL, but we had the notion of three components, sorry, OWL-S, or DAML-S, I should say. We had these three components. We had the idea that there was a profile which would describe what a service would do, and it could be used for advertising services or putting in requests for services. And these described the types of inputs that a service would actually expect, or the outputs that they were generated, as well as taking an AI perspective, what states of the world would permit a service to be invoked? Is it invocable at a certain time? Are the necessary prerequisites enabled for it to be executed? And of course, because these things could have a tangible effect on the world, they would then have subsequent post effects, or which would need to be asserted in some way. But of course, as we'd often talk, you could order a pizza, but if I order a pizza from Beauty's in near MIT, I know the pizza is going to be great, but I'm living 3,000 miles away. So I need to make sure I'm actually considering the other parameters. So where these services are, have their physical manifestation, can they actually provide a quality of service? Some of these parameters became really important later on in the use of such semantic web services. For example, within the science grid, if you're using a service to do some form of experiment, what is the data precision? Is it appropriate for the type of experiment you want? What would be the cost of making use of this service? How reliable is it? What is the return time? So these things became very much more important than we realized because of their actual usability. Of course, we had the process model, which created so many research papers and I'm sure PhDs, because they looked at that notion of composing processes. So taking atomic processes, which could be atomic services or representing atomic services, and then composing them together to provide some form of workflow that would achieve some complex goal from some simple goal. If you think back to one of Jim Handler's challenges to us, it was to say, it's my daughter's birthday in a few weeks' time. I'd like to get all of the books from the Harry Potter series, but all of them in hardback that could be delivered at the most reasonable the most reasonable price possible, but ideally being shipped at the same time. So there were a number of different factors that you would need to consider to try to assemble that and actually deliver it. If you're interested in how you solve that problem, Bijan Parsi actually produced an excellent piece of work with Evan and Jim on coming up with a solution for that. But we were looking at that type of composition. And of course, it was building on many of the standard control constructs that you find in business process modeling. And another good person to check out if you want to see where that's emerged nowadays is Chiara Ghidini's work on thinking about the semantics that you can use for modeling processes in some way for workflows. We then needed to ensure that these services were grounded, you could execute them. And at the time, WSDL was actually emerging as one of the main frameworks for describing the interfaces of services that would then be invoked over SOAP. Admittedly, there was the whole issue of RESTful services that were emerging, which simplified the use of service invocation so much for developers in general, but they weren't necessarily as formal as WSDL. But we tried to look at how you could ground DAML-S within the WSDL framework, so that then when you came to invoke a message, you'd use standard pathways. Whether or not they were sending just data types or knowledge fragments is another issue, but it would be a way to actually invoke those services. So when you look back at that, it was a great effort, a lot of interest. Certainly, so many people were interested in trying to address the issue of service composition and looking at building different frameworks for building services. And of course, the profile provided a very simple framework for advertising semantic web services. There was also, remember, great work that was coming out from Europe at the time. It almost feels like there's that Europe-US centered approach, but there was the work from the problem-solving methods leading on to WSMO. That was very much from Dieter Fensel and many of his colleagues looking at how we could actually make use of various logics to actually provide services. As I said, building up on the work that Enrico, that John Domain and others were doing on problem-solving methods. I'm sure there are names I'm forgetting here. Forgive me. So there was a really good momentum at the time in, from around 2003 to about 2008 in using services. And of course, some of the advantages of whether you were using OWL-S or WSMO, you actually had what were de facto standards for services. They weren't full official standards. They became candidate, both of these became candidate recommendations with the W3C, but there were certain problems, which I'm about to come on to. There are also the idea of these semantic web services were also essential with much of the evolution of the e-science grid, where you would have even devices and physical machines that would be described using some of these service descriptions that could then be used. If you look, for example, with Carol Goebel's MyGrid project, where she was looking with her team and collaborators at bioinformatics systems, they found that they could build often very complex, in some cases up to 700 services that you put together to look at complex bioinformatics problems, where you're thinking about how you take genomes and you break them down, or you're testing them in some way. So there were parts of this that really did have utility. There are many other areas that they've been used, and you still see papers talking about OWL-S. It's still being in use even now. And of course, remember, there was a proliferation of web services that were emerging at that time as it was becoming used more and more seriously by industry. But there were serious problems looking back at OWL-S. In many ways, it was clunky and very difficult to use. You've got the classic problem of having to model knowledge and make use of other ontologies to be able to ground your services in. It was almost unrealistic at the time to expect service providers to be able to put that much knowledge engineering and not have the ability to put in that level of knowledge engineering. So another problem that we had with the OWL-S profile was, as soon as you started thinking about complex services, you had the problem that there could be a simple way of characterizing the service that would be used for advertising, and that would differ from the actual use of the service depending on the inputs and outputs that would actually be required by that service, especially if that service was modeling a complex workflow that may have different paths through it. So in a way, there was a loose association between what was the actual requirements of the process model that gave the details of how you'd invoke a service and its various steps compared to the profile itself. If you look at the process model, I remember many of the conversations, even with colleagues, thinking about how do you make use of description logics to describe process modeling? Probably most of you out there are tearing your hair out saying, you can't, it's not the right formalism for this type of thing. So many times we'd be trying to say, how do you describe a workflow that could have loops and therefore state changes with description logics? It's simply not the right formalism to use for that type of thing. There was another issue. We saw the issue of composition versus choreography that was emerging. So orchestration was thinking about how you would actually describe how the different services could be put together, building up that workflows. But if you think about that dialogical interaction you might have with the service, so thinking more of its choreography, what agent or what party is responsible for what part of the communication to invoke a service, it wasn't really the right support for that. And finally, the OWL-S grounding. I'm not sure anybody liked it. If you did, tell me. But there wasn't that much adoption, as I recall, on that, because the idea, or rather the proposition of SAR-WSDL, semantically enabled WSDL, followed around that time, and it very much took the momentum of that type of work. Now, from an autonomy perspective, thinking about an agent perspective, much of this work lost its link to the notion of multi-agent systems and the idea of supporting agents. It was very much service-focused, but didn't necessarily consider the issues to do with autonomy. I mean, you could argue that taking an autonomous agent, it needs to know about its peers. It needs to be aware of their capabilities and potentially their roles. It needs knowledge about the norms of the environment, what is permissible and what is not permissible, and when does a certain action become permissible. What are the policies? Yep, there was some great research emerging. I remember Tim Fine and Alana Kagal were looking at Ray as a policy language back in the day. And there's been great work, certainly in the last 10 years, on encoding policies for the semantic web and using them. Some great papers that have emerged, certainly recently that I remember. But this wasn't being addressed or supported back with that OWL-S. It simply made the assumption that you could provide this data. And I've included just something on the right, just to remind people of the notion of speech acts. And, if you consider a little, a fragment that you could put in the knowledge graph saying the door is closed, that's a statement. But how you interpret it can be, especially in communication, can often be due to the type of communication you have. Are you including a different performative or a speech act with it? Because, of course, with the statement, the door is closed, am I asking, is the door closed? Am I asserting that the door is closed? Am I asking another agent for the door to be closed? We've focused very much on services from a functional perspective, but, of course, the work on multi-agent systems assumed that any agent could acquire knowledge as it was moving around, as it was interacting with other agents, such that when it acquired the right knowledge, it could proactively decide to perform actions rather than being instructed by a third party. And let me just remind everybody about WSMO, because there was great work that came out of WSMO. It came from a different genesis to OWL-S. It was thinking much more from a knowledge perspective. And in many ways, there were things that addressed that OWL-S simply didn't consider. The notion of mediators, and these could be aligning goals, they could be aligning ontologies if they came from different domains. It could be thinking about how you connect these web services. There were many, many great and interesting ideas that came from the WSMO community. Because, of course, they had realized that fundamentally, if you have an open system, you need to align these ontologies. This was something that OWL-S didn't even consider because it was felt that this is what other researchers do. And it was part of the general machinery that you would have in order to bring services together. But this is still a fundamental challenge, even now. If you have an agent or a service that's assuming some ontology, and then you find another domain that actually another ontology that's in the same domain, but it has a different representation, it may have a different complexity. How do you bring them together? How do you align them? After all, when you think about it, ontologies are very much contextual. I realized I should have included a slide here. I remember a great conversation with Pat Hayes once where he was saying that, if you're interested in bridges, you could have an ontology describing a bridge. And of course, if you're an engineer, this could be rich in the way you use different materials and how they come together and the anatomy of a bridge. Of course, if you're the military, all you care about is how to destroy the thing. Your focus and requirement on exactly the same domain is completely different. So how can you potentially bring these things together, bearing in mind that actually the purpose and the use, the context for which you're trying to transact with a service may require a variance in that alignment for it to be fit for purpose. So so thinking about that, I'm going to talk a little bit, not necessarily as self-advertising, but to talk about some of the things that I've certainly been involved with a number of different colleagues over the years in how to move on from that, learning from what we did with Semantic Web Services and the challenges that we tried to address and that's still addressed. And these feed into the notion of how we still need to introduce knowledge within an agent system, but how agents can actually support knowledge-based systems. One example would be for services within bioinformatics. So, some of the early work there was just finalizing some of the syntactic interoperability problems and looking at how we could actually discover services to bring together for complex workflows. But what was realized was that the web is a great infrastructure, but very occasionally web requests fail. There's no guarantee. So, of course, if you consider there's a possibility of failure, then you've got the problem that, sorry, I'm just moving this other window. No, I'll leave it there. You would actually find that you may have a service that goes down or is unable to complete. So, of course, one way we actually address this, and I had a student looking at decision support for this, was how can you describe a workflow that has, or a goal that has a very specific abstract workflow for it, and then provision the services on the fly at runtime in order to achieve that goal. But then should there be a failure, be able to find another service that even had perhaps was still performing the same type of capability, or achieving the same capability, the same type of knowledge, although it may be described in a slightly different way with a different ontology. How could you find it, provision it, include it in your workflow, and execute it? Well, if you've got that difference in ontology, it's still somewhat problematic. If at least there was consistency on the ontology, you could make the reliability of that service far greater. Furthermore, if you had issues to do with timing, availability, cost, you could reason about these and to ensure the guarantees of success to some extent, or at least being able to minimize, for example, cost or delay in achieving those workflows. Reliability becoming incredibly important. But of course, much of the work that I've done over the last 15 years now has actually been thinking of alignment, and specifically autonomous alignment using mapping or correspondence fragments that already exist. How can you actually take many of these, and this is with collaboration mainly with Valentina and Tama, but with several others as well. How can you actually try to identify, potentially from different alignments that may be generated using a wealth of different approaches, how can you identify the correct correspondences that would be consistent, coherent, but fit for purpose to be able to align two services? And this could be done purely as a one-shot approach, but better, can you do these dialogically to see how, as one agent says, I think this is the type of correspondence that I would need, but it obviates the possibility of using a different correspondence that the other would need without having a one-to-many or introducing a violation with respect to the ontology itself. So we've also done work with Alessandro Solomando and Ernesto Jimenez Ruiz in seeing how you can modify those alignments to overcome errors that could occur as you're bringing these things together. I even had one student try to make use of game theory to try to see how we potentially could make the right choices in working with the services, not necessarily knowing what that other agent would actually need in order to find that alignment. The point being is that alignments are an inherent part of the semantic web, as are the use of the ontologies, but in picking the right one at the right time due to an emerging and open environment, you need something more. You need that support that isn't necessarily human-focused or human-driven, but is autonomous in that way. And that brings us on to the challenges that we still have today. And, you know, I've had great conversations recently in talking to colleagues about this, where you think about knowledge graphs, how they differ from the traditional semantic web and how they can be used for autonomy, because we still have that desire within autonomous systems to be able to describe services or even things. There's the whole Internet of Things and Web of Things. How are they described? I mean, remember that in many ways, devices are no longer characterized by a name, but rather by their capability. You may think of there being a photocopier, for example, but it's actually a scanner and a printer simultaneously. So often devices can have multiple uses depending on their environment. Even in my home with my Internet of Things, I have a proximity sensor that tells me what temperature it is. Odd, but these things are being integrated. So we need knowledge about these things so that agents can then, as they move into a new environment, identify serendipitously the appropriate services and talk to them or communicate with them in some way to achieve a better goal, to enrich the experience for a user. And often these can be described or reasoned about using business process models. So how you make use of them may often require some form of curation or observation. Likewise, the work that's on buildings of norms and institutions, how different components can come together and when they should come together is still very important. But of course, the thing that I'm interested in, and I want to pose almost as an open question to the community today, is that knowledge graphs are making incredibly important inroads in the research of using knowledge, as I'm sure you're all aware. But where are the roles that autonomy can actually provide? I mean, I recall conversations many years ago where sometimes there would be a fallacy in the understanding of what an agent was. Oh, isn't it just a piece of code that has a configuration file? No, it's how you can actually reason about the current situation about your knowledge. It's almost, I don't want to say it's a second order reasoning of knowledge, but it's reasoning how you acquire knowledge, who you communicate with to get that knowledge, how do you facilitate and bring it together, curate it, assemble it. How would you actually check the veracity of knowledge where you're getting some information, but there are points of verification in some way? And is that even relevant? Another classic problem that we have, especially in making use of services, is privacy. There may be a requirement for two services to interact in some way, but some of that knowledge may have to be confidential or proprietary, especially if you're looking at business services. So how can you still facilitate that interoperation whilst taking into account those privacy issues? So I'm coming to the end of my talk here, but I'd like to acknowledge I've got quite a long list. I've worked with a number of people and had an excellent experience when working with some fantastic people out there. So I'm not even going to try to go through some of the names, but all of these people have been involved in the work that they've been involved in the eGrid, or many of the projects that I've been involved with, the eGrid, with DAML-S, thinking back to the CoAB's work, and of course more recent work in the forays into policies, norms, and knowledge graphs. So I'd like to thank them all. They've been fantastic to work with, making great contributions. And well, that's me. Questions?
Okay, so thanks, Terry, for that very interesting talk. For our virtual front row audience, maybe open your mics and let's have a bit of applause for Terry. Does it work?
Thank you.
So we have a bit of a delay for YouTube. So for the time until questions come in, maybe I briefly introduce here Antoine.
Mm-hmm.
Antoine will host a Q&A session. And as we keep questions come in, maybe a few words about Antoine. So Antoine is part of the leadership of the cost action, and he's also co-chair of a W3C community group on web agents. So we think he's very qualified to host this Q&A. And as questions come in, I want to hand over to Antoine to run this this session.
Thank you. Good evening to the European audience, and good day to the rest of the world. There are people elsewhere. So I'm looking at the question, and Andreas asked has a question. Description logics not suited for processes with loops and state changes, quote, That's a quote, more or less what you said.
Yes, that's true.
And the question is, what type of logic, if any, would be suited?
Oh, now I'm not the person to ask for that type of thing. I remember being in conversations. We had Drew McDermott talking with Bijan and others, trying to understand how you could describe the idea of concepts that potentially could be changing. I don't want to even think about how you'd be able to reason temporally about these. But as far as the types of logics that you could actually use to represent these, not being a logician, I'm not sure I would want to venture into any comments, but certainly there were temporal logics that have been used within the agent community to model the execution of possible actions. But I'm not going to actually put my foot in it. I'm sorry.
Yeah,
question.
I've seen work that use temporal logic for these kind of things. So
yeah.
Well, I have a question myself, but I see that there is another channel from the Zoom chat. Tobias is asking a question. You mentioned that the proliferation of web services was something that went in parallel with the DAML work. What did the decline of web services to the work? What did the, there might be a word missing. You said the service grounding not appreciated. Is this what you meant? Tobias, if you can clarify with opening your microphone.
So you said later in the talk, you said that service grounding was not appreciated really. Is that what you meant, or is it a different development?
I guess you could say that. I can imagine David Martin out there will probably bury his head in his hands at the thought. But the problem at the time was we were trying to look at how you could invoke those services. And arguably, the connection through to actually invoking specific services was more problematic. As I said, there was a huge amount of research going on with the composition of services, but not necessarily their execution. And as I also mentioned, Saltwurstel emerged as an alternate way with alternate links to describe the execution of services. Now, there's been a lot of work since that time on services themselves. If you were to ask me what's responsible for changes in web services, say in the last 10 years, I honestly couldn't tell you there. But what we found that there was a reduction in the use of semantic web services. I think as it was realized that whilst they could solve, in theory, they could solve many problems, in practice, actually making use of them for pragmatic solutions was becoming problematic because of all of these inherent problems with alignment and ontologies, etc. So we saw a drop off by around 2008, 2009, certainly by 2011, I would argue, in interest in semantic web services, and a much greater focus on the annotation of knowledge and the use of that knowledge, such that in a way the community has really thinned out since.
Thank you. So I said I have a question.
Please.
You presented with the history of DAML-S, OWL-S, and so on, a lot of things that were based on description logics. You also said that some other formalisms maybe should be needed for processes, etc. I'm wondering how moving towards knowledge graphs rather than the description logic-based logic or structure can help, or how using knowledge graph distinguishes these approaches from the previous ones.
That's a really, really interesting question. And I'm not sure I have the right answer for you. To my understanding, I'm not sure we can actually easily represent knowledge process models in knowledge graphs, and it's something that I'm curious and I'm actively looking into at the moment. Linking to other formalisms that could be used to present those processes, or at least referencing something that potentially is therefore consumable by another agent, may be the way to do this. Again, it comes back to how you make use of the formalism. I don't think you have to stay, or I don't believe you would necessarily have to stay within a knowledge graph formalism itself. I guess you could present it abstractly within the knowledge graph, but I'll be honest with you, you're asking me on the logic side of things, which I'm less familiar with compared to colleagues. I'm sorry.
But maybe the difference is with what is not logical. In knowledge graph research, there is a lot of activity related to things that are not really logical, like knowledge graph embeddings, or all the database aspect of storing data as graphs and so on. Maybe this is the difference.
It's an interesting, yeah, I like that. That's interesting. Yes, thank you.
Okay, so but you don't have any more comments on these?
No, I'm afraid I'm not. You've caught me on the hop there, I'm afraid.
I don't see. Oh, Andreas has again asked another questions on the YouTube chat. What could be a low-hanging fruits in terms of tasks and applications?
Ooh, that's an interesting one. Low-hanging fruit for tasks. I'm trying to think of something off the top of my head. I'm getting a string of questions that I'm having trouble with answering here. I guess the issue is if you're thinking about no, I had something in my head and I've lost it. I'm sorry. Andreas, I'm not sure I can give you a good answer to that.
Well, he added automated composition. Maybe it was not a very low-hanging fruit.
I think a lot of people are interested in automated composition of. Certainly one could perhaps argue that business processes would be something that we should really be making better use of. There have been various models that we can actually use and perhaps encode using knowledge graphs. Arguably, that would be a thing that we should be looking at there, because I know that there's great work in modeling those process models and being able to then identify points within that flow where you need to inspect it, verify its validity, etc. So that could certainly be something that perhaps we should be looking at.
And perhaps if you knew some low-hanging fruits, you would have grabbed them yourself already.
I do try to sleep between the hours of 2 and 4 in the morning, but yes, you're absolutely right.
I don't see any more questions in the chat on YouTube and neither on Zoom. So I guess we can thank you again. Or is it? Oh, new question from Ross Horn. What about sticking knowledge graphs inside existing process composition models, such as session type?
Now, that could be a really interesting proposition. That's actually a really good idea. I mean, certainly there's that issue of being able to enrich the current descriptions that you would have of services. And actually thinking about it now, I would also argue there's in the exchange of those services themselves, having the appropriate fragments that are comprehensible by each of the different stakeholders within a model, within a business process model or a compositional model. But no, I think that's a good idea. I think that definitely has legs.
Thank you. Okay, so I don't see any more questions.
Mm-hmm.
So I guess we can thank you again, maybe little virtual applause. Tobias, would you like to make the conclusion and wrap up this session?
Yes. Thanks again, Terry, for coming, for giving that very interesting talk. To conclude today's session, I can only advertise the next talk, which will be on December the 7th by Mayank Keriwal from University of Southern California. We will give the details on our website and advertise on the usual channels. That would it be for today. There's also applause on the YouTube channel. So thanks again, Terry, and thanks for everybody for watching. Please cite and like and subscribe. See you next time. Bye-bye.
Yeah, thank you.